Good morning, everybody. Thank you for joining us for how to decommission a data center. I hope everyone is enjoying the fantastic weather we're having here in the UK. I know most of our attendees today are here from the UK. My name is James. I'm going to start with a couple of quick bits of housekeeping. So we're scheduled for 30 minutes today, and it's something we're always very keen to stick to. We're very grateful that you'll join us for webinars like this, and we like to respect your time, make sure you can kind of get back to things on schedule. So we have a section on the right hand side for you to be able to type in any questions. You will also find there's a section of handouts. Now in there we have a checklist of all of the kind of key items that you need for decommissioning a data center. You can grab that and download that now, or alternatively, we are recording the session and we're going to distribute that afterwards, so don't feel you need to kind of scribble down things as we're running through. If you need to refer back to it, you'll have the recording and that checklist, as well as a couple of the other resources that we're going to talk about as we go through the session today. And I want to start with two things. So firstly, the question of why you might be decommissioning a data center and how that ties to us, why it is that it's something that we're talking about. And the reason that I guess it's something we're also keen on is we're involved in an awful lot of data decommissioning projects, predominantly through disaster recovery and backup service setup. It's one of the main reasons that people will choose to engage with us, because they're decommissioning a data center. So one of the main reasons that you might have multiple data centers is for resilience and redundancy, whether that's high availability, periodic replication for like a warm disaster recovery site, or just sending backups to that site. But as hardware is reaching end of life, a lot of people are reviewing that and thinking, is it a good decision to continue to reinvest, to buy more, and to continue to operate and run multiple data centers? And really, one of the big reasons that's contributing to this change is, I think, for the first time, there's now a very, very viable alternative to running your own or running multiple data centers of your own. I think let's say there are folks who are early adopters of cloud computing, and there are lots who are far more conservative, whether that's for security reasons or because it's, for any number of reasons why it's not the best option for you. But certainly, I think at this point it's almost kind of unanimous that the cloud, and particularly public cloud computing, makes perfect sense for infrequent or sporadic workloads, things like seasonal demand. If you've got rushes for Christmas in retail, if you've got fundraising activity in the not-for-profit sector, and that ties perfectly with, I guess, what we're calling here, it's the kind of cloud economics. So there are plenty of reasons why you might choose to use cloud computing for reasons other than purely cost. But if you have a demand that is very, very infrequent, then it makes a great deal of sense to pay only for what you use. Hopefully, you've probably seen similar graphs to these a kind of 100 times when you're talking about the kind of the OpEx versus CapEx model in cloud computing. And I think that is it's the single biggest driver for why we've seen a big change in the number of people decommissioning their own data centers. And then the last reason that we want to talk about this is that certainly over the last 18 months, every organization that we deal with, every person I speak to, personally and privately, or friends, businesses, I think everyone's reviewing what they'll be doing going forward in terms of office space, and what knock-on effect that then has for data centers. So I'll finish this kind of intro with, as all webinars, a stat from Gartner. Now this disclaimer, this stat came from the research in 2019. So in 2019, 10% of enterprises said they were closing their traditional data centers, and that was going to shift to 80% by 2025. Now, 2019 obviously is not long ago, but feels like a lifetime in the kind of pre-COVID days. It would be interesting to see how that's changed and what that's going to be like in future when that 80% in 2025 is different. So on to the meat of what we're going to talk about today. So this is the checklist. As I say, this is all available with kind of further detail in the handout, and this is what we're going to run through of all the detail things to think about when you're doing your decommission. And we're going to run through these items. We're also going to talk about a couple of scenarios and some examples to hopefully try and kind of bring it to life and give you an idea of how these things could be applied in practice. So the first item of these kind of three broad sections is the discovery stage. Now, you might look actually to drop back, you might look at these. If anyone had attended a webinar that we held a little while ago on setting up disaster recovery, you probably notice a great deal of crossover here because there's a lot of similarity in these two projects. But we'll start with discovery. So this is where projects really do tend to succeed or fail. If you have issues later, you can almost inevitably track them back to gaps or shortcuts in this process. And this is where it's better to spend the majority of time to make this work. So right at the top, we've got defining the scope for your project. Now, you'll need to create a more detailed scope of work later for the specifics of the project, but you want to start by setting out what's your kind of high level aim. Why are you doing this? Next up, we have setting the budget. Now, obviously, the purpose in I think the majority of decommissioning projects is going to be broadly to save money. But the project in itself, obviously in the short term, is going to have a cost. There may be external suppliers that you need to engage with. There'll be the disposal of hardware, etc. Those things will be informed by some of the later stages, but we think it's important to kind of bring this in, bring this in as early as possible, set expectations, make sure everyone's kind of aware that what's likely to be the kind of high level budget for the project. Point number 3 here is setting the timetable. Now, this is for us. This is actually a kind of a really good thing in these kinds of projects because there is almost always some kind of external impetus for the project. You might have hardware that's reaching end of life or will be out of support by a certain date. It might be that you're in a commercial data center, you're in a co-location facility, or it might be that you're closing an office, and all of those things are good kind of hard deadlines, good kind of drop dead dates that you can then work backwards from. And for us, in our experience, these kinds of projects where you've got those kind of firm deadlines, they're the ones that people tend to work to and hit those deadlines. It's the ones with slightly softer deadlines that often tend to kind of run longer. Point number 4 here we have is identifying who the stakeholders are. Some really obvious ones. You've obviously got the IT team. You've got the team who are going to be handling the migration itself. You've got the users of the specific systems. But there's also some people who will need certain bits of information at specific points within the project. A kind of classic example for that will be finance, who will need to know when you're specifically not using the assets anymore and they're being decommissioned. Point number 5 is selecting your project manager who's actually going to run this project for you. Do you have someone internally with the skills and, most importantly, the time to be able to do this, or do you need to bring in an external project manager? And that ties into the next section, which is selecting any suppliers that you're going to need to help with the project. Now, there's lots of companies who specialize in data center moves, in migrations, in decommissioning projects like this. What I will say is there aren't necessarily any skills that your team wouldn't have themselves internally. There's no reason this isn't something that your internal team wouldn't be able to do. With that being said, these are pretty intensive projects. There's a lot of man hours involved. More often than not, I think people don't necessarily have the kind of spare time to do that. If you're too busy, if you're on all of the BAU work, and if you've got a tight deadline, it's a good idea to bring in a supplier that can help manage the project for you. And then the final point here, which is the really, really kind of big one, which is creating the inventory of assets and your dependency map. And I want to make a quick note here, actually, because so the title of this webinar we're talking about is decommissioning a data center, and data center can mean a lot of different things to different people. We could be talking about a handful of servers for a small business and an on-premises server room or a kind of remote office. On the flip side of that, we could be talking about thousands of servers in a colo facility, or even your own setup in a public cloud facility. All of those setups should follow the same checklist that we're talking about today. The difference will be the level of detail and time and effort that will go into each of these stages. So particularly here on the creating of a kind of your inventory and your dependency map, this is something we do a lot of when we're setting up disaster recovery for a company, because obviously we need to know what those dependencies are of servers when we're recovering and bringing them all back. Hopefully, when you're kicking off this project, you're not starting from a standing start. You will have some detail on this already. If you're ITIL, you're going to have a service catalog, for instance. Hopefully, you have a configuration management database. That being said, and so this is something we know from experience, whenever we do these projects, inevitably there will be detail in those repositories that needs to be updated. In almost every project, we end up making amendments and fixing and going back and updating that as you work through. You may, if you've got a large environment, it's a good idea to run some automated discovery tools so you can get software to run across the environment. What you're trying to get at this stage is all the detail about the assets that you're going to be moving, all of the networking, and importantly, how each of those services are dependent on each other. Now, as I mentioned, this is something we do. We do this a lot for our disaster recovery projects, so much so that we created a kind of free online tool to help do some sort of simple dependency mapping. So this is available online. It's in tools.databarracks.com. We'll include the links with resources that we send over after the fact. And here you can add each of your individual services. Here in this example, we're looking at email. As I mentioned, we produced this tool for disaster recovery dependency mapping. So you can add in, what you're adding here is your recovery objectives, so your recovery point, your recovery time objectives. And the purpose of this tool was to be able to set out where you were, and then if you're trying to make a change and improve those things, where you would like to get to. Once you've added all that detail in, you then drag and drop and pop in all of the assets. So in this case, this is an on-premises Exchange server, domain controller, storage, etc. And then once that's fully populated, you can then add all of your kind of remaining services, HR services, finance, and then generate your report. And then online, it will produce some simple dependency maps. So here we've got all of the assets on the left-hand side, all of the services on the right-hand side, and you can kind of toggle between them. You can toggle between your recovery objectives, whether it's kind of where you are and where you want to get to. So relatively simple. And then once you kind of reach the end, you can export all of this into a PDF, and you've got all that detail. So it's a free tool. It's useful. We'll include the links for this at the end. It's really useful if you've got a handful of services. So for smaller organizations where it's perhaps 5 to 10 services and 30 to 100 servers. Beyond that, I'd certainly recommend looking at the more automated software tools that you can run on the network to do the dependency mapping. And then the last point on kind of getting that inventory and all the detail that you need is it's not all about the physical assets themselves. There's also things like locating all the licenses, always one of those things that I think tends to get forgotten, certainly when we do disaster recovery projects and when you need to move assets and licensing needs to change. And then things like digging out all of the contracts, not just colo contracts, for instance, but also things like maintenance, etc. And at this point in your kind of discovery phase, you can start to think about what are the things that you get to keep, and then what are you going to need to add once the data center's been decommissioned. So firstly, is there any hardware that you'll be able to keep and reuse? What are you losing and what might you need to replace? So for instance, if you are losing your second data center that you use for DR, you obviously need to replace that with something so that you have resilience. And then lastly, what are the knock-on effects going to be of that change? One sort of simple and obvious one here perhaps is if you are replicating between two sites and you've got an MPLS network where you've got networking connected between the two, and you're removing that and you're planning to use the public cloud for disaster recovery, then perhaps you need to think about the external breakouts for internet connection, whether that's something that needs to change as a result of that initial change. So I'll try to kind of highlight these in a couple of quick and easy examples. So first example, this is moving disaster recovery to the cloud. So let's say in this example, you have an office which is in Manchester, and that's both your headquarters and it's your primary data center. So you've got an on-premises server room with all of your infrastructure. Now, you also have a second site, which is London, which you have people in the office, and you also have hardware there, but the hardware exists purely for disaster recovery, and we're replicating between the two. Now, first thing that you do when you lose that site is you're going to need to set up disaster recovery in the cloud. Here we're suggesting that it's going to replicate into Microsoft Azure. But the thing to think about in this situation certainly has been our experience is you may not be able to reduce your hardware footprint at that London site down to absolutely zero. You may have to keep something there. So at its most basic, if you're running, and by this I'm talking about the infrastructure that's needed to support that office. So if you've got everyone using virtual desktops, you could just be using something as simple as setting up Wi-Fi in that office, but more often than not, it will be a firewall and a switch, potentially even local domain controller, depending on the setup. So although you're removing that data center, probably making a massive saving in lots of different areas, whether power, cooling, storage space, etc. But there may be a requirement to keep something locally. Now, the other example here is if you're closing down the office altogether. So it's not just a case of the hardware's reached end of life and you don't want to continue keeping that on. You're actually losing that office. So let's say kind of scenarios we have now for an awful lot of people, you've got expensive London rents, you're choosing not to kind of keep that up. Everyone's happy working from home. So the decisions come to close down that office altogether, make a big saving on the lease, and send all the staff to a Regus or a WeWork serviced office. Now, if you lose that office, the first stage is obviously going to be the same thing, which is to set up your disaster recovery to another site. Here again, we're saying Microsoft Azure, but in this case, it's pretty unlikely that the lease of that office is going to coincide with any maintenance contract. So you're highly likely to have lots of hardware that's left over, something that you can perhaps redistribute to Manchester. Perhaps you've got other smaller satellite sites, and that could be anything. It could be anything that you've got in that data center. Obviously, physical hardware itself, the servers, but racks, UPS, any of that infrastructure. So onto the implementation stage. Now, the first couple of points here, we said once you've kind of finished your planning, are around backup and disaster recovery. So we're still looking at this is a situation where the secondary data center that you are decommissioning is something that you are using for resilience. So if that's the case, as has been here, the first thing you need to do before you can fully decommission is you need to set up backup and replication into the public cloud, into Azure with a disaster recovery as a service provider, wherever that might be. You need to do all the testing to make sure it's all working, and then you need to make some decisions about what kind of cutover you're going to do. Is it a big bang or is it a phased cutover? The positive thing here, if you're just changing your disaster recovery site, is that it's a pretty simple switch over at that point. Once it's up and testing and working, you can do the equivalent of a big bang. It's more kind of pretty simple one where that's turned off and you're just now relying on your new DR setup. On the other hand, if we're talking about decommissioning a production data center, that's something a little bit different. So I've got a second scenario here, and this is something that we can actually talk about from our own experience here at Data Barrack. So we obviously have lots of customer systems that we host in data centers all over in the public cloud, but we're a medium-sized organization ourselves. We've got our own infrastructure, and we've had that in a number of different places over the years. We previously had an on-premises in the office server room. We've then moved that to a co-location facility, not where we host customer data, somewhere separate, so we have the resilience there. And then lastly, we've done a migration from there to Microsoft Azure for our production systems. And the way that we've done that has always been a phased migration. So the good thing about doing that is you set up your new site. In this case, if we're talking Azure, it's a kind of simple process of setting that up, getting it all networked, getting it attached to the production site, getting this kind of the basic infrastructure set up, And then the positive thing about doing a phased migration is that you can then migrate the individual, here we're talking about VMs, but an individual service one at a time, which is the way that we've done it on all of those occasions. And the good thing about that is it takes a great deal of pressure off the migration team. You significantly reduce the chance of there being kind of major downtime when you do that if you're aiming for a big bang migration. And it lowers the stakes. If there's a single service that you bring across which doesn't work, you can revert back, you can make sure that it's working properly, you can then bring it across. With that being said, you will have a number of almost smaller big bang migrations as part of that phased migration. So inevitably you'll have some services that are dependent on a number of items of infrastructure. You need to bring all of those at one point. So there are some of those slightly larger migration pushes, but over time you can do it all at a kind of much lower pressure situation. Now, the downside of doing a phased migration like this is that you're running two sets of systems in parallel. There's two issues. There's one, obviously, you've got the cost implication, and secondly, it's a thing that these kinds of migrations are something that we were able to do because we didn't have a firm deadline. Obviously, we talked about at the start about how often there are hard deadlines for these migrations. For us, these were all choices. We weren't being forced out of any situation from the kind of the former production site, but it does mean that it does take significantly longer. So kind of just something to be aware of. Now, the one item that the team who handled all of our migrations here were really keen that I should stress is the thing that they found most useful when they were doing their migrations was that actually before you get to this point where you're migrating those individual services from your former production site to the new production site, is that actually to do some test migrations locally. I think we've all got systems that perhaps don't get taken down very often. It's a good idea to do that local test because obviously if it's a great way to kind of unearth any issues before you do the full proper test, but pushing it to a second data center. Because if you can't do it locally successfully, then inevitably you're never going to be able to do it to the new data center. And a quick kind of side point here about sort of the shape of IT for most organizations now. Now, everything that we've been talking about so far has sort of presupposed that all of your infrastructure, particularly if you're running a kind of single predominant production data center, is in one place. And that's not really the case anymore, particularly over the last sort of 18 months when there's been really rapid adoption of 365, Teams, Zoom, etc. All of those things. For us, the vast majority of organizations now have some kind of hybrid IT environment that's some on-premises IT, some cloud productivity suites, and potentially even some production IT in one of the public clouds, and AWS and Azure. Now, that's really good in a number of ways because you're spreading your risk. It's far less likely that you're going to have an outage that affects everything. But it does have as a knock-on effect with what your decisions are for resilience, where you want to have your replicas, your redundancy. Now, it's much easier to set up DR and resilience within the same cloud. If you are running your production environment in AWS, you can set up your resiliency across multiple availability zones, even push that across regions. And it's far easier to do that than it is to set up an equivalent high availability across multiple clouds to be AWS into Google or AWS into Azure. It's possible, but it's more complex and it's more expensive. So it makes sense to architect your environment that way. With that being said, you certainly don't want to keep all of the eggs in one basket. Obviously a terrible idea. So if the majority of your data is in one of those particular clouds, for us it makes a lot of sense to at least have backups being pushed to a completely different disparate cloud. That's something that is far easier and has less of a cost implication. So if the majority of your production environment is now going into Azure, pushing off your backups into AWS, Google, etc. So just kind of side note on that point, because when we're talking about decommissioning data centers, I guess it's a bit more of an fluffier concept at this point. And then the last section here is on disposal, which relatively simple. So there's obviously the shipping of hardware that you're able to keep to other sites. There's recycling or disposing safely of anything that won't be reused. And then there's the secure destruction of any disks and any data. Now, I'm not going to spend any time talking about this because these are things that inevitably everyone's already doing. You've probably got relationships with secure disk disposal companies, etc. So just the thing to factor in here is the time and the additional expense that's likely to come at this stage. The final example that I want to share today is something a bit different. So there's a fantastic video case study from Spotify. This was at one of Google's big events a couple of years ago, and it was about their migration to Google Cloud. I thoroughly recommend watching it. It's 45 minutes long. It's quite long, but they really get into the details and the specifics of their migration. And even if you're not similar in your setup to Spotify, I think there's a lot of lessons that can be learned. I'll include the link at the end, and I'll include it with all the resources that we send out. And for me, it's a really interesting case for a couple of reasons. The first is that Spotify is a very, very large organization, so there's that in itself is interesting. And secondly, unlike a lot of what we've talked about previously, where we're talking about relatively simple systems, a SQL server, an Exchange server, things that are in everyone's kind of back office setups. Spotify is a software development company. They build the streaming app. So for them, this was a big migration of their microservices architecture of Spotify, the app itself. And there were a couple of kind of really good learnings from it. So firstly, if we look at the scope of what their project was, the reason they were doing it, this was a migration of their production on-premises IT environment into Google Cloud, and they wanted to do that because they wanted to get rid of all of their IT infrastructure overhead, and they just wanted to focus on developing that app. And their goal was to move as quickly as possible because they wanted to minimize their costs of running multiple systems in parallel. Now, with that being said, even with that as their goal, the migration of this scale took them 3 years to do so. They prepared for 2 years before the migration, and then it took them a year to migrate. And I think that's a really good kind of rule of thumb, really good indicator for where the split of time and effort should be going into. 2/3 into the preparation stage, 1/3 into the actual migration itself. They split up their migration into their services side and their data side. The services migration was 1,200 microservices. And for context, an individual user request in Spotify takes between 10 and 15 microservices. So microservices architecture, obviously great in software development for speed of development and bringing features through. But when we mentioned earlier, unpicking the intricacies of dependencies, you can tell obviously here just how complex that would be. And the way that they then did their migration, they looked at how much data they needed to move, and it was a vast amount of data. So they did a phased migration, and as they were migrating between 50 and 70 services per week, they were bringing the data that was required for that. For them to do all of the data at once was going to take between months and a year to do so. So really, really interesting. Lots of kind of good learnings in that. But the one thing that I think is the best sort of simple takeaway from this that hopefully everyone will be able to use, they created this visualization on screen as a kind of an indicator of where they were in the project. And the red bubbles are systems that were still on premises. The green bubbles were things that have been migrated. And I think this is amazing because if you think of the amount of time that a project manager during a project like this would spend updating people, trying to give people a sense of where you were in the project, this at a glance, you can tell exactly where everything is. Perhaps not everyone's going to have the development resource to be able to build something like this, to do a kind of live visualization of your migration. But even if you can't, it's a simple thing that perhaps you could do. You could put up on a whiteboard. You could put it on a single PowerPoint slide. I think it's a nice, simple takeaway from their migration. So the resources that I've mentioned today, then we have the PDF that's available in the handout, and we'll include the link to that. We have the webinar of how to set up disaster recovery that I mentioned in passing, and the technology dependency tool and the video for the kind of full explanation from Spotify about their journey to the cloud. We are just about up to time, but I think I've got time for. I'll try to squeeze in one of the questions. I promise for all the other questions, we'll get back to people individually and answer them together. And actually, and this is a very good question. So, shouldn't we consider refactoring? Which is a terrific question. It's a very, very big question. So when you're migrating systems, I think particularly this applies to cloud migration. Perhaps you may have heard of, I think it's called the 5 R's. There's rehosting, refactoring, re-architect, rebuild, and replace. So refactoring, certainly, yes, a very good point. And I guess at the two ends of that scale, you've got rehosting, where you're kind of lifting and shifting, taking a server from one place and rehosting it somewhere else. Replacing, that's where you're changing a system altogether. Perhaps you're moving from an on-premises server to software as a service, and you're completely shifting to the service. And then all of those items in between is I guess that word that Spotify are in, where you're redeveloping your application to make it work in the cloud. Yes, that's a very, very good point. It's certainly something when you're looking at migrating those production workloads into the cloud, but I would say it's probably a bigger topic than we're covering today, and it's certainly something that I would recommend bringing in some experts to help with that, because those are projects that do take a lot of time and a lot of work to make sure you're making those applications work well in the cloud. But really good question. And with that, I should close things up today. I'll let you get back onto everything you're doing. Thank you all for joining us, and I look forward to seeing you all on our next webinar.